Let's talk instead about a mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen. July 4, 2025, the same day the world celebrates independence. It loses something far greater, the illusion of cosmic solitude. Across the globe, radio telescopes are tracking a familiar intruder. The name hasn't been uttered in years. Penstar spotted an object moving rapidly between the stars. And this time, the usual follow-up measurements of position and speed showed something completely different. Yet, it carries the weight of an unsolved mystery. Oumuamua. But this isn't the drifting silent object that slipped past us in 2017. This time, it's on a controlled trajectory. Every adjustment in its path is precise, deliberate, and one voice turns the moment into a global conversation. But to make sense of this alien return, the origin has to be understood. Flashback. The first encounter in 2017. October 19, 2017. On the slopes of Halia in Hawaii, the Pan-STARRS telescope catches sight of something unusual, a faint streak against the black. By the time astronomers realize what they've found, it's already on its way out of the solar system. The object is unlike anything ever recorded. It isn't bound by the sun's gravity. It isn't looping back for another orbit. It's passing through and leaving. This is the first confirmed interstellar visitor in human history. Its name chosen in Hawaii where it was discovered is Oumuamua, messenger from afar, arriving first. At first, it's classified as a comet. But there's a problem. No glowing coma, no dust tail, nothing that marks it as such. It's reclassified as an asteroid only to be given a brand new category altogether. I for interstellar measurements suggest an object somewhere between 101,000 m long. Its brightness pulses every few hours as it tumbles in space, hinting at an elongated cigar-like shape, or perhaps a flattened pancake. It reflects 10 times more light than a typical comet, making its surface appear unusually bright. Its path is hyperbolic, a clean escape from the sun's grip. At closest approach, on September 9th, it blazed past our star at 87 km per second. But the real shock comes as it leaves. Instead of slowing under the sun's pole, Oumuamua accelerates just slightly, but enough to defy every known law of natural motion for an object like this. There's no visible gas jet, no dust, nothing that would explain the push. Infrared scans find nothing either. The data is limited. The window to observe it closes in weeks, and what little we learn doesn't match anything in the catalogue of known space objects. Astronomers are left with a puzzle. One that natural explanations strain to solve and that some will soon claim might have no natural explanation at all. But the debate over what Oumuamua really was would prove to be only the beginning. Theories and debate after 2017. With Oumuamua now vanishing into the dark, the only thing left was the data and the arguments over what it meant. Some scientists leaned toward natural explanations. One theory suggested it could be a fragment of nitrogen ice blasted from the surface of a Pluto-like world in a distant star system. Such a fragment shaped and smoothed over millions of years in interstellar space could account for its unusual brightness and acceleration without leaving a visible trail. Another proposal described it as a hydrogen iceberg, a body made almost entirely of frozen hydrogen, releasing invisible gas as it warmed near the sun. Hydrogen would escape without producing detectable dust or a visible tail, making the outgassing effectively invisible to our instruments. A third possibility labeled it a dark comet, a body without the glowing coma or tail we associate with comets. In this view, hydrogen trapped deep inside ice crystals could have been released after long exposure to cosmic radiation, producing thrust too subtle for traditional comet science to explain. But there was another theory, one that refused to sit quietly on the sidelines. Harvard astronomer Ave Lowe argued that Oumuamua might not be a rock at all, but technology. His idea, a light sail, a wafer-thin craft no more than a millimeter thick, propelled by the push of sunlight across interstellar space. The suggestion split the scientific community. Lowe published detailed arguments pointing to the object's extreme shape, unusual acceleration, and lack of typical cometary signatures. In response, Cornell researcher Darrell Seligman and others countered with their own analyses, defending natural explanations and challenging Lowe's assumptions. The result was an open public back and forth alien technology versus exotic natural physics. Yet, for all the theories, none could fully explain the object's strange mix of properties. Too shiny for a comet, too fast for an asteroid, accelerating without visible fuel. Every model solved one part of the puzzle, but none solved it all. And so Oumuamua left toward Pegasus carrying a secret no one could crack. But the mystery was far from over, because 8 years later it would return and bring an answer no one saw coming. The return changes everything. 8 years after it vanished into interstellar space, the unthinkable happens. On July 4, 2025, Oumuamua is spotted again. A faint but unmistakable object against the black. Its trajectory cutting back toward the inner solar system. Astronomers immediately recognize its signature motion and brightness profile from 2017. But this time, something is different. Tracking stations begin feeding in new positional data. At first, the readings seem like noise. Small deviations from the predicted path. But as more observations come in from observatories across the globe, a pattern emerges. The object is not just coasting along its orbital curve. It is making deliberate changes to its course. The corrections are precise, timed, and controlled. Adjustments so exact that they cannot be explained by outgassing, gravitational nudges, or any other known natural process. Each maneuver requires enormous energy, the kind of sustained thrust and control that no drifting comet or asteroid could produce. For scientists, the shift in thinking is immediate. A theory that had once been labeled fringe, the possibility that Oumuamua was of artificial origin, now stands supported by direct observational evidence. Papers that had been dismissed or criticized in 2017 are suddenly back in circulation. Even astronomers who had firmly argued against the idea find themselves re-evaluating old positions in light of this undeniable data. The return becomes a global story overnight. Major news outlets replay archival footage and graphics from its first encounter. Documentaries are re-aired. Interviews with researchers resurface, and the unanswered mysteries of 2017 are retold for audiences who now see them in a new light. Social media platforms ignite with theories, analysis threads, and amateur tracking updates, while live streams follow its approach in real time. Governments quietly instruct their space agencies to maintain constant observation. The private sector joins in with commercial satellites and deep space tracking networks, turning their instruments toward the incoming object. Every hour brings new updates. Every update feeding into a wave of anticipation. And then the biggest twist of all arrives. Because as Oumuamua approaches, it does something no one was prepared for. The signal first contact. The first detection is faint. A narrow band of repeating pulses hidden in the static of deep space. At first, the signal blends into the background noise buried in the constant hum of cosmic radiation that every deep space receiver collects. But once the initial recordings are run through filters, a pattern begins to emerge. Observatories on multiple continents confirm the same thing. It's not random noise. The pulses repeat in a way that follows a deliberate structure, sequences of prime numbers, progressions based on geometric ratios, and precise references to physical constants that are the same everywhere in the universe. These are the hallmarks of a crafted message. The kind of signal scientists have long theorized would be used to announce intelligent origin. As the decoding work begins, something remarkable happens. The message seems to unfold in layers, each part containing instructions for unlocking the next. Built into it is a framework for understanding its own language step by step, as if the sender anticipated the challenge and prepared a guide. This isn't just a distant transmission saying, "We are here." It is a carefully constructed sequence showing exactly how to listen. For the first time in history, humanity holds recorded, verifiable evidence of intelligent life beyond Earth. Every dataset is independently checked and rechecked, leaving no room for doubt. The debate over if has ended. What remains is the far more urgent question of what is this: a greeting, a warning, an invitation, or something else entirely? In response, the global scientific community shifts into action. Research alliances form almost overnight. Cryptographers, linguists, mathematicians, and AI engineers begin round-the-clock work sessions, sharing progress in real time. Data flows freely between institutions that only weeks before had been rivals. The focus is singular. Crack the message before Oumuamua moves beyond range. And as the race to understand begins, one unlikely place becomes the campfire where millions gather to process what's happening. Joe Rogan, the global campfire in Austin, Texas. The red on-air light glows in a studio known to millions. Joe Rogan leans into his microphone with a half smile and a shake of his head. His voice carries the same mix of curiosity and disbelief that much of the planet is feeling. It's back, folks. The weird space cigar is back. The sentence needs no context for anyone listening. Oumuam's return has dominated global headlines, television panels, and online feeds for days. By now, its name is etched into the public consciousness. Every person tuning in already knows the basics, but they want more. Across from Rogan sits Avi Loeb, the Harvard astronomer whose 2017 claim that Oumuamua could be alien technology once drew skepticism, criticism, and even ridicule. Now, with the object's recent controlled maneuvers and the structured signal confirmed by independent observatories, Loeb is no longer a controversial voice on the margins. He's the central figure in the biggest scientific story of the century. The conversation between them is direct and grounded in evidence. They revisit the events of 2017, dissect the details of the new trajectory data, and explain why no natural object could behave in this way. Loeb walks through the physics, the calculations, and the light sail hypothesis that once made headlines for all the wrong reasons, but is now receiving serious attention. Rogan steers the interview into territory few traditional media outlets would touch so openly. Are we about to get a phone call from ET? Who decides if we respond? Are governments telling us everything? The discussion flows between technical science, unanswered questions, and the larger implications for humanity. Loeb stays precise and analytical. Rogan brings the questions and doubts on everyone's mind. Together, they create a space where complexity doesn't get lost. The signal from Oumuamua ignites a global reaction. Millions tune into broadcasts, while religious leaders, philosophers, and artists wrestle with its meaning. For the first time, the question isn't abstract, it's real. Humanity has proof we are not alone. Around the world, observatories work non-stop to decode the transmission. Patterns emerge, suggesting the message is structured to teach. But with discovery comes division. Should we reply? Some warn of danger, others see silence as a lost opportunity. Who should speak for Earth, and what should we say, science, art, or something simpler? At the same time, scientists prepare for future interstellar visitors. New observatories and missions like Project Lyra aim to study, even chase, Oumuamua itself. From its mysterious arrival in 2017 to its return in 2025, the object has changed everything. The question is no longer if contact is possible. It's whether humanity dares to answer.